Moss specializes in construction. We're a construction company at heart.
Yep.
But our clients prefer for us to be EPCs. Think about it as if you're building a house. Do you want to hire somebody to build you a house, or do you want to hire the electrical contractor who's going to do the wiring? Do you want to hire the person who's going to design your structural, and then do you want to hire the person who's going to build your structural? For us, it's really easy because they just say, hey, I want a plan. That's it. They're hands off. They're done. We handle it for them. I think a lot of people are scared of like, hey, AI is going to take my job. To me, I think we're living in an era where it's basically the computer revolution all over again.
Yeah.
Like the person with the computer is going to replace the person who doesn't want to use a computer. Now it's the person with the AI who's going to replace the person who doesn't want to use AI. I think an interesting technology to watch is going to be perovskite panels. If it proves to be an actual 15-year life, the fear behind it is not really a proven technology. What if it ends up being 6 years?
Yeah.
That totally changes the idea. Because if we're really seeing a 15-year decay, these modules could be game changers.
Welcome back to yet another edition of the Sounds of Solar podcast. I'm Christoph Bruhn, your host today. And Russ, hey, put your hands down. You know what to do with your hands. Actually, it's that. There's Russell Hamilton. He's a co-host today. And Mr. Mike Benitez joining us from Moss Construction. Mike, how are you doing?
I'm doing very well. Thank you for having me.
Greetings. Well, Russ, we were just, all three of us were just talking about our favorite films growing up. I feel like that's a nice little segue.
Okay.
What's your favorite comedy film from the 90s?
Favorite comedy. Come back to me. I got to think about
He's
that. He's
going to think about it.
Well, I wouldn't say 90s then, but my favorite film of all time is also a comedy, which would be Princess Bride.
Princess Bride, classic. Another
I've
Mel Brooks
never
movie.
seen that movie, and I've heard it's like a movie you must see.
I'm absolutely disappointed in you.
Yeah.
And may God have mercy on your soul.
I'll go home tonight and watch it and report back. So if we're just saying any comedy, not 90s, yeah, Super Troopers is probably my favorite.
So what year did that come out? Like 07?
Earlier than that.
Earlier than that?
02, 01, 02.
Yeah. So anyway, we have Mike here today. Very excited to have you on the Sounds of Solar podcast, Mike. Thank you for coming.
Second time.
This is the second time.
Second time. Welcome back.
Yeah.
Yeah. This
Liked it so much,
Yeah.
Kids are excited that you're on here. Hi, Mike's kids.
Yeah, they're some of our OG subscribers, in fact. So
Yeah,
that was great to hear.
Yeah.
We had you on Gateway to Solar. That was when was that?
No.
That's a long time
Gateway
ago.
to Solar?
It was
Yeah.
Gateway to Solar.
Clean Power. Clean.
Yeah, clean.
American
or wait,
Clean Power. It was American Clean Power.
it was Clean Power. What did I say?
Gateway to Solar.
For those, yeah, it's Clean Power. I knew that. That was a test. You all passed. We had you on Clean Power, and when was that? That was like a year ago.
It was like May of last year.
Yeah, about a year ago.
Time is an illusion. I
Yeah.
don't even know what time.
That was our first semi-live. Wasn't really live, but we did some
Quasi-live.
quasi-live.
We were living during it.
Yeah. No, you did the phone live thing.
Oh, yeah.
And I was like super late.
You were super late.
Well, it was a big
And we couldn't hear.
conference
Remember, we
room.
couldn't hear anything. We'd have headphones on.
Yeah.
It was
Yeah.
horrible. I was like, "What'd you say?" Couldn't hear anything.
Yeah.
We
made
we
improvements
learned because we put headphones on when we went
at
live.
Gateway.
At Gateway. So
See?
we didn't do Gateway
Yes.
live,
Yeah.
which was great.
Yeah.
I had to sit in the room by myself.
What for what?
Don't you guys remember?
You were in
'Cause
the,
you had
We didn't have enough.
Didn't have enough chairs
gear.
and mics.
So
I had to go
Russ
sit
just
in the-
like
I had to go-
left and
yeah.
sat by himself while
Crying.
other people
Time
had
out,
fun.
like all by yourself.
Time out.
Little
Yeah.
side hat.
He's gonna do that too during this one. We're
just
just
I'm in timeout. What can I say?
Get out of
Yeah.
here.
No, I was back there watching it, waiting for my cue to come back. And
Yeah.
was it when Logan took off?
Yeah. Something like that. Hey Logan.
Fun times.
Anyway, so we're here with Mike today. Mike, who are you? Remind our listeners, what is it you do?
What is it you
What would you
do
say
here?
you do
What
here?
did you say you
Yeah.
do here?
So I was born in Miami, Florida.
Yeah.
No.
I've heard of it.
Long
Small
walk on the
town.
beach
I
and
mean,
stuff,
people
you know?
rarely hear of it. And so originally from South Florida, grew up kind of, my parents were Cuban immigrants. And they were like, hey, my dad was like, one of his like life goals was like, hey, I want to like put somebody in college and like have them like go through college and like, and do something with their lives. Like my dad never even graduated high school.
Mm-hmm.
So he was like, yeah, I want to do this. And I was like, man, I really would like, he's like, what do you want to do? And I'm like, well, I want to build stuff. I like building stuff. I like putting stuff together. I like kind of building, designing, creating things. And kind of knew I was going to be an engineer kind of early in my life.
Mm-hmm.
And with that said, I was fortunate enough to go to the University of Florida, got a bachelor's degree in, go Gators, by the way, in electrical engineering.
Which is the best engineering, by the way.
Which is the best engineering, by the way.
Sorry, Chris.
I
It is.
think,
I'm just a comedian these days. I just on the show. I don't know.
So yeah, while I was there, I was looking for a career, looking for a job, trying to figure out like, hey, what do I want to do? Like, I like building stuff, and my aunt actually was worked for Florida Power and Light, and she was like, hey, you should try working for FPL. I've been here for like 35 years. It's a great company, and like you should get into power. Everybody's gonna need power. They're gonna need power forever.
It's ubiquitous.
Yeah, so it's like, hey, you should really get into this industry. And I was like, well, that seems like a good idea. So I applied for a job, and I heard nothing from them. So I was like, I heard nothing.
Oh, okay.
I heard nothing. And so I like to say the story was really easy there, but it wasn't. So I went to work for a small electrical contracting firm, and it was kind of far away. My girlfriend at the time, who's now my wife, was still at UF, and I was commuting back and forth from like the job was in Miami. I was going back and forth to Gainesville. About 8 months into doing that, I get a call from Florida Power and Light, and they're like, "Hey, you applied for a job like a long time ago.
We just found it."
Yeah, we just found it, and I'm like, and I had no idea. Like, I didn't remember what the position was about.
Yeah, yeah.
I remember I applied. I just don't. I didn't remember what the job was, and I was like, "Yeah, I totally remember that." I was super excited for that position. Had no idea what they were calling me for, and they're like, "Yeah, we think you'd be a great fit. We want to bring you in for an interview." And I was like, "Yay!" And I'm like, "That sounds amazing." And so I'm like, "Let's do this." And applied, went in, and just trying to find old emails, trying to figure out like what it was I actually applied for. Had no idea when I showed up, but apparently I did well because they offered me a job.
Nice.
Perfect.
And it was considerably more money. It was way closer to my girlfriend, and I was like, hey, this seems like a good fit all the way around. Let's do this. It also was in my girlfriend at the time, well, my wife's now, but her hometown.
Yeah.
So she's from Sarasota, also from Florida, and so it's like, hey, let's go to Sarasota. And so I worked for Florida Power and Light for about 5 years. Started off my career there for about 2 years doing distribution design, which is essentially the design of like, hey, I'm going to build this building, get me power.
Yeah.
And I have to figure out like, hey, where's the closest power line? How do we get it to you? How do we get the easements we need? What do we need to do to get you power? And what impact is it going to have on the grid? And did that for about 2 years and was like kind of replaced myself with Excel spreadsheets. And was like, this is kind of not, when I was thinking about building stuff and like coming up with the future, I was like, this is kind of pretty easy and not very exciting. And heard from a friend of mine who was doing protection and control on the substation side.
Sure.
And goes like, this is like super exciting. I use my degree every day. I don't deal with clients, and and I get to like, troubleshoot all these crazy issues. And I'm like, that sounds amazing. Like, I want to do that. And so I went to the protection and control engineering side, which is essentially, for putting it in a small box, it's somebody else would design like the planned projects. I only design projects that like exploded.
Yeah.
It's like, hey, this broke and it wasn't planned. So can you fix it? And I get to design that, see what spare parts we had, figure that out, engineer in there. And then also we do what's called commissioning, which is essentially the verification that everything in what we do is, custom engineered. And like any custom engineer normally goes through some kind of performance testing to figure out like, hey, how is this going to work? It's the first go round of design. It's a prototype. Basically, everything we build is a prototype.
Right.
And it's like, how do you make sure that it's going to work? And so, did that for 3 more years, and got an opportunity from a coworker to go work for him in Colorado. And so at the time, my wife and I were like, hey, let's go to Colorado. And this is kind of exciting.
Yeah.
Neither one of us had been from Florida. My second time ever seeing snow was on my interview for the job.
Okay.
Because they made me go out for an interview, and basically the interview was, hey, how are you doing? Here's your offer letter. Would you like to join us?
Where was that? Where in Colorado?
So I lived in, the position was kind of in Stapleton, or near where the old airport was.
Okay.
I lived in Highlands Ranch,
Okay.
So kind of southwest Denver. The office eventually moved to Centennial, and I think it's still in Centennial now.
Okay.
Because I know they just recently moved. But yeah, so I worked for EPS for a while, and then Moss, who I work for now, ended up being basically a client of a client.
Okay.
So, at EPS, I went from basically like entry level, like kind of field engineer, to eventually their Western Division Vice President. So I managed everything on the Western U.S., basically all of their operations. And I worked, a client of a client was Moss. And heard about the opportunity that Moss was presenting of like this senior director of engineering. And I was like, hey, that's kind of interesting. So anyways, I ended up having a 30-minute call with Alfredo that lasted 3.5 hours.
Sure.
Which I know Alfredo's been on this call before, or on this podcast before.
Yeah.
And so if you guys talk to him, 30-minute call.
Oh, yeah, it
3.5
can go
hours.
long.
That makes sense. So it was kind of an interesting opportunity. So the idea was, hey, we're an EPC. We do the E, which is the engineering portion of that. But we don't actually do any engineering in-house. But we want you to kind of sort of start like a subject matter expert group. And we want you to kind of help expand and diversify our engineering management portion of that group. And I thought that was pretty interesting.
And when was this again?
This was 2022.
Okay, not that long ago.
So about 3 years ago. So I've been in this industry now for about 20 years. 20. Oh wow, that's a long time. So I started December of 2004, so about exactly 20 years.
Okay.
So it's been like 20 years and like 2 months.
In your position now, I know you kind of said it, but you're the senior director
of engineering.
of engineering. Okay.
So I think the senior just means I'm old, or I've been doing this for a long time.
It's implied.
It's implied, at least. So I oversee Moss's engineering group, which essentially is a mix between 2 departments. It's like basically it's 2 teams, 1 department. And the one team is engineering management, which is basically the team that works with our EOR partners, like our awesome partners like EVS. And then the other team is basically what we call our SME and like engineering services team. And essentially it's the little bit of engineering we do, which is more at like the early design stages of the project, more just to support our estimating efforts, also to provide some technical support and kind of QA, QC / challenging to the
It's
EOR
like a
partners.
technical liaison.
Technical, yeah. So essentially, if we have a question or concern, or like, hey, why would you do that? Why would we have? We have 2 projects side by side. Why are these 2 different? Somebody to be able to look into that, dig into it, and be able to challenge kind of our EOR partners.
Yep. I've been there.
Wait, you were on that side too, or you were the one being challenged?
He's been the one being
I see,
challenged.
Yeah.
I may have challenged them a couple times.
Oh,
That's been good.
It's been good. Yeah,
It's all
that's what we're
friendly
here for.
jabbing.
No, I mean, one thing about this industry is, right, we all want to do well by our clients.
Yeah.
And that's how you get repeat business.
Right.
It's doing good work. And I think everybody knows that we're all human. We all make mistakes.
Yep.
And it's kind of cool to challenge it. And then when you put a lot of heads together, you get a lot of cool products. So as we work on these things, we can lean on each other's knowledge, figure it out. Like, hey, why are we doing this? Why wouldn't we do this? Like, hey, this new standard's coming out. Why wouldn't we try that?
Yeah.
Well, our desires are the same. We want to all build the best project we can with the tools we have available to us, but our perspectives are different, right? Because you guys are the E and the EPC, and we're the E.
You guys are the
through
E.
you.
Yes.
So like but you have to build it. We engineer it, but you build it, and we see things in a different way, and that's.
Yeah, it's like it's so important to understand. So most engineers, okay, maybe I'm speaking out of turn, but I think most engineers don't have a background in any type of construction.
No,
So
not a
when
lot of hands-on
So
experience.
when they're engineering something, understanding how something goes together maybe isn't at the top of the list. So that's where we get the perspective from you guys is, this is why we don't want you to engineer it that way. Maybe it's way more efficient to do something differently. Because when you're talking about, 100,000 piles, I don't know.
That's accurate.
Or whatever
Yeah.
we're doing.
Yeah.
It might sound something very simple, but compounding it over and over and over again, labor is extremely expensive.
Yeah.
Yeah,
Can you talk a little bit more about the other aspects of an EPC? Maybe just quickly go over what an EPC is and how it functions in the solar world.
EPC is engineering, procurement, and construction. So something that kind of resonated with something that you said earlier is like, hey, you as the engineer, you specialize in engineering. Honestly, Moss specializes in construction. We're a construction company at heart.
Yep.
But our clients prefer for us to be EPCs. And what does that mean, right? Well, think about it as if you're building a house, right? Do you want to hire somebody to build you a house, or do you want to hire the electrical contractor who's going to do the wiring? Do you want to hire the engineering firm who's going to design the wiring? Do you want to hire the person who's going to design your structural, and then do you want to hire the person who's going to build your structural, or do you just want a freaking house?
Yeah. Because theoretically, you could do that, but that sounds like a giant pain in the ass.
Yeah, it's exactly. So for us, and it also provides, to be fair too, it also provides one throat to choke, right?
Yeah.
If we make a mistake, it's not like, hey, it was somebody else's responsibility, as opposed to in the other scenario I gave you. It's like, hey, they designed that wrong, so it's their fault. Go yell at them, And it's like, well, for us, it's really easy because they just say, hey, I want a plant. And that's it. They're hands off. They're done. We handle it for them. But ultimately, we're a construction company. We want to build projects. One of the things that Alfredo will say is we're little E, little P, big C. We do the E and the P so we can do the C.
Yeah.
So like at heart, we're really a construction company, but we partner with firms to help us do the E, and we'll do the P if a client wants us to.
Now, however, like for the procurement part of that, it usually goes pretty hand in hand with the construction, right? I mean, like.
Yeah, I mean, it can. We have done projects where we're just the C.
Yeah.
We've done projects where we buy everything.
Yeah.
Except for modules. We'll never buy modules for lots of reasons. For one, I mean, the biggest one, I don't know if people realize this, but modules are half of the cost of a project. And so as a firm, if we're going to buy that for the client, we'd have to mark up half the cost of the project just to buy it. And like nobody wants to do that.
Yeah,
Right.
That's a huge risk, especially anyone doesn't know, modules are volatile. It's part of the industry. So if you can, someone who maybe specializes in that should probably do that.
And actually, there's another spoiler for modules.
Here we go.
So yeah, spoiler.
Yeah.
But that said, overall, I mean, we're like when we went to the E, the P, and the C, it's really we'll build the projects. We'll partner with an engineering firm to help us engineer, but that doesn't really tie into some of the estimating portions. So the reason we have a small engineering group is really to help us figure out, like, how do we bid a project? How do we put in a decent proposal for the project? But we have to have some kind of internal resource to do that.
Sure.
So you mentioned, okay, Moss is a little E, little P, big C. So talk about construction in the solar renewable space and how, I don't know, just at length maybe.
Sure. So, I mean, obviously, like every other market in the world, construction has evolved. Back when I started, there was a lot of focus on, basically, like, how do you do individual piles? How do you how do we level them off? How do we make sure we're going to do ground? Figure out. Now we go into GPS, right? Like GPS will give us like pile height tolerances and all types of things. Even like the grading now is pretty much programmed into the
grading machines.
The grading machines,
Yeah,
and they just
exactly.
basically go through and follow the plan.
Yeah.
As opposed to somebody trying to eyeball it and go, I think it's close.
And that's only changed in the last few years.
Yeah.
I mean, we have had the technology 10 years ago, but it's only become relevant in the last couple of years, right?
Yeah, and then you follow in like drones following with topography. It's so easy to do a topo nowadays. Where you just fly a drone. There's even services that provide, companies that provide like drones in box that they can fly them remotely. You just basically keep the box plugged in, and the drone just takes off whenever it's programmed to do so.
I didn't know that.
It's pretty crazy.
That's kind of crazy.
Yeah, so there's lots of things. What's interesting about it though in our industry is how much the growth has happened.
Yeah.
And with that growth, you need to be able to provide infrastructure for that growth.
And scale, et cetera.
And scale. It's like being able to train people, being able to get to those type of levels. Moss really started doing like true EPC work probably around 10 years ago.
Yep.
We did projects before that, but we were more construction management than turnkey EPC. And
how does that work like 10 years ago when you're only going to build it and other people you're taking those inputs from other organizations? Like, how do you even manage that? Like, if you're not doing the procurement, you're not doing the engineering, you just get a set of plans and.
So essentially it's more schedule process management at that point. So a lot of like open visibility and making sure you're basically increasing transparency about the different groups and getting a good feel for when things are going to be on time, like kind of developing out a construction schedule and making sure that the pieces get there when they're supposed to get there. And like I said, a lot of it is just more making sure that there's open areas of communication.
Communication's key. Relationships are key. If
100%.
all those things are in place, then it makes everything a lot easier.
So let's I was curious about like perspective of a construction team. So say like a 75 megawatt project, how big is the construction team personnel wise?
So I would say at the peak,
Sure.
probably 175 people,
Okay.
200 people.
Yep. And they got to like live in that area.
Yeah, they got to live in that area. So you got to, so essentially when you have that type of situation, like there's usually it's not really easy to find 200
Right.
trained people who know how to build solar projects in that area and 75 megawatts nowadays is relatively small.
Right. I just know that Moss does a lot of 75 in Florida.
In Florida, yeah.
Yeah. We do bigger ones, obviously.
Yeah.
Outside.
Nowadays, though, 75 megawatts is relatively small, and that's obviously AC, not DC.
Right.
So as you get outside the state, or, throughout the country, you know, projects that are, we're
1.5.
we're working on a small little project, right?
1.5 gig.
Yeah,
1.5
it's
gigawatts.
very tiny.
Yeah.
little tiny.
I think it's actually 2 gig because they're going to do that phase 4 at some point in time.
At some point.
Well,
Not including the battery storage.
Right.
Well, maybe let's riff on like a 200 megawatt DC or AC project. Something these are like
pretty common.
kind of the
Yeah,
what we're building
yeah.
nowadays.
So how
And
many construction folks for a 200 megawatt peak construction?
For 200 megawatts, it doesn't
Yeah.
scale linearly.
Okay.
You know, it's not one of those things where you can build, if you take, 200 people and I build it and I add 400 people, I don't get it done faster. You know,
Right.
There's
'Cause there's a
limit of
process,
scale.
right?
Yeah, there's a process.
Right.
There's a workflow that goes through it.
Yep.
And if you have too many people in the same area, it doesn't really increase production at some point, right? It actually does the opposite.
yeah.
Diminishing returns.
Yeah. So when you get into there, you're probably looking 300 or so, 350.
And how
And that's
many?
got to be a logistics like nightmare to like you said, find, because we talk rural areas most usually, right?
Yeah.
And so where do you find places for these folks to live? And then like, how do you get folks to go there, to work? That's got to be a logistics nightmare.
how do you do the thing?
How do you do the thing? Yeah, how do you do the stuff?
So, a lot of it is like we have an amazing HR team that goes through and like they're really dedicated and focused to it. Kind of our ambition, our worthy goal for what we do is basically we want to improve the lives of the areas we go in and touch.
Yeah.
So a lot of it is just like kind of going in there, providing training, a lot of recruiting, a lot of like, hey, we can and we actually do a lot of recruiting even within areas of the sectors that people don't normally recruit in.
Okay.
One of the other things that we go into, and I know everybody's scared of it, but ultimately I think it's going to be kind of part of the future is automation. It's learning how to do better processes, learning how to figure it out, learning how to train people, learning how to make plans and showing people like, hey, here's work instructions that show you how to do your job. But also at the same time, like as we get into like, kind of the future areas of this, I think a lot of people are scared of like, hey, AI is going to take my job.
Yeah.
Well, what's kind of cool about this is our kind of ambitions were very, very high for what we wanted from out of the power system. It's like, hey, I just want to like start adding things to the grid.
Yeah.
I want to add electric vehicles. I want to add AI.
Data centers.
Data centers in general. I want to do all, and I want to replace aging infrastructure.
Yeah.
I want to have population growth. I want to do all these things, and I want to do it all at the same time. And it's like, how do I keep up with that demand? And to me, I think we're living in an era where it's basically the computer revolution all over again.
Yeah.
Like the person with the computer is going to replace the person who doesn't want to use a computer. Now it's the person with the AI who's going to replace the person who doesn't want to use AI.
Yeah. So you're just augmenting the way you do tasks in a different way. It's no different than like, I'm going to make a document on my computer. It's like, I'm going to make a document on my computer with the help of artificial intelligence that does this certain task that you have to get experience with it to understand how it helps you. And that's like going to extend to everything in our society, which is insane.
I think a really good example of that is like drafting.
Yeah.
You look at drafting 40 years ago, 30 years ago, and you look at it today.
Yeah.
With AutoCAD and Microsoft.
Yeah, and you look at some of the the planning softwares that you have within like just PV sites, right? Where you can say like, hey, I want to try using these modules instead of these modules, and it'll just say okay, and they'll try to AI tool create a different method of doing it.
Yeah.
Still have to have somebody look at it and figure out because it will still make mistakes, just like a person.
Yep. So got to QC it.
Yeah, you still got to QC it. You still got to know enough to QC it.
Yep.
But ultimately, it can give you multiple scenario planning pretty quickly.
Yeah. What would you say the biggest challenge to construction in general is for a solar plant?
Biggest or largest?
Like
Or
right
multiple
now?
ones? Like,
Yeah, like
Yeah,
right,
right
now.
now.
like right now, I mean, I would say it's a
I say biggest and largest. I mean, see what the difference.
I mean,
is.
I would say from a technical side of it, it's getting experienced people who know what what they need, trained,
experienced people.
yeah, like knowledgeable people on projects.
Yeah.
And be able to
So the
disseminate
labor
that over
part of
scale,
it is-
and
yeah.
then scaling that effort as
Okay.
it continues to grow.
Yeah.
Because our industry is doing this, it's
Yep.
like how do we continue to grow? I don't know if it's backwards on this camera or what.
We'll fix it in post.
Yeah. So I would say that, and then I would probably mix it within the supply chain.
Supply chain.
Yeah.
I mean, there's still things that are kind of long lead times with kind of like still post COVID. I mean, I know
Yeah.
it feels like it was years ago, and it really was.
It
but-
was
5 years
yeah,
ago?
Yeah.
Yeah, pretty much.
Yeah.
And what's crazy about it is you still have some ripple effects of things like people that shut down, they were caught up,
Yep.
and it's like they had to do a whole catch up thing while we're increasing growth dramatically.
Yeah.
And as you get these, it's funny because everybody in the past will always be like, hey, we put this plant online, it'll power X amount of homes.
Yep.
And like people don't realize that like one AI facility can use like 40% of that power.
Yeah, exactly.
So-
And then by extension too, like was that calculation taken into account that
Of course not.
all these that and then every house now has an EV suddenly,
That's the other
or
thing, yeah.
things like that, and
Yeah.
it's just crazy. So like in the last 5 years, like have certain items of the supply chain remained difficult while other things have improved? I mean,
I would say that overall, yes, I would say things have shifted. Prices have changed, and then you have like an extension of like lead times on items. You can still get them. It just might be, a year now before you can get it.
right, instead of 5.
Instead of it being a couple weeks.
Oh
it
yeah,
goes to like a
right. Yeah,
year.
the opposite problem. Yeah.
Yeah.
So experienced people, biggest issue, and supply chain, second biggest issue. Probably cost the most. Supply chain.
Yeah. So I mean, supply chain. Yeah. There's so much. There's volatility in that.
So with the people, right? You all doing a great thing, right? This apprenticeship program. I was an electrician, so I went through apprenticeship program. Super helpful, and I do think it's like really helpful that you guys have this apprenticeship program for solar construction. Do you all? I'm just curious. Like, do you visit tech schools or
Oh yeah,
stuff like
absolutely.
that? Like, try to like get involved and like,
Yeah, we actually have like a major recruiting effort, and a big thing we do is we do a lot of like on the salary side, we do a lot of internships.
yeah.
I think we have something like 200 something interns currently,
Sure.
right now.
A lot like out on site or just
yeah,
mixture.
all over.
Yeah.
So in sites, in the office, even within engineering, we have some interns.
Alfredo said he was an intern.
Fredo started off as an intern.
Yep.
Yeah.
Yeah.
I did not.
No, you came in with some experience.
But yeah, Alfredo started off as an intern, but ultimately, yeah, we do a lot of internships.
I mean, it's like as that being a big problem, like, do you see it in the future being resolved?
So, it's one of those things where it's kind of interesting. So you had this uncertainty, right? With and I know like this is more of a technical conversation or anything, but we had some uncertainty with like kind of new changing political climates and all these things are going on, but we had crazy lofty goals. So I think what happened really is like we just kind of changed our goals to be more reasonable, and what I think they were going to be either way.
Yeah.
And so I think there's like kind of that mix in like, are the goals too lofty? But then I think also like some of the automation stuff will help kind of offset some of those ideas. But even within like trying to find, like even engineering partners, as you start to add on projects, it's like, hey, we can only handle X number of projects at the same time, and we'll try to work with our clients to like, hey, can you stagger this project a little bit so that we can shift crews over and keep kind of crews busy in the same areas. But a lot of it is very focused around like, how do we train the people up to be able to do the work that we need to do?
Sure. And that's like, I mean, even in the engineering part for solar, I mean, we have that issue too of, just electrical in general is electrical engineering in general. When I went back to school, because I'm non-traditional, like I was researching what would be a good engineering field to get into. And electrical was at the top of the list because people weren't going to school for it, number one. And everybody that was in the industry is getting to retirement age. And so, we talk about solar on top of it. There's just not programs out there that are, prominent with like educating for people to come out and go straight into solar.
Mm-hmm.
Yeah. Well, I mean, and even power in general.
Yes. I had 2 power classes available at my university.
Yeah,
That was it,
same,
just 2.
Same thing. So
Yeah.
I had this exact same thing when I came out of my bachelor's. Actually, I was fortunate enough that I got my master's, and my master's was built out of a program that Floor Panel Night created with the University of South Florida.
Yeah.
And so that one was very geared towards power.
Yeah.
But that was a very strange thing to have. It wasn't very common.
Right.
But yeah, also it's weird that people don't want to get into electrical since it is the best field of all.
It is the best field. It is.
Yeah, if you look at it in the dictionary, it says right after the definition, it is the best field, in fact.
So
Yeah, but it probably says it in Latin, which makes it sound way cooler.
Yeah, that's the other thing.
and the thing about electrical, the program, and I looked this up when I was in school, is that it is the most time-consuming, most difficult undergraduate degree to get.
I started in electrical, and
A lot of people
Got
start
weeded out.
electrical and they end up in like finance or like accounting.
I went to civil engineering.
Yeah. I'm just saying, like, but a lot, like at NDSU where I went, they like it was. That's where the business school got their recruits were, from the electrical department. So kids would be there for like a year and they're like, oh, this is not for me. But they're good with math. All right, let's go do accounting. Let's
There you
go
go.
do something.
You know what's funny is I switched into electrical engineering. I was actually started off in mechanical engineering.
Oh, well,
There you
that's
go.
that's
Yeah.
an understandable segue.
Yeah.
I was like, when I was in mechanical engineering, I'm like, I don't know, I just don't find this interesting as much as like electrical. There's this magic force that we could
Yeah.
use to do things.
Right.
And
The
it's
Schwartz.
yeah,
Schwartz.
yes.
No, I got into it I was an electrician, and how I became an electrician was funny. I was having kids, and I was like, I need to do something. I need to go back to school. And I closed my eyes and I pointed at the screen and landed an electrician. Swear to God, that's what I did. And then I was like, oh, okay, I'll give it a shot. I was halfway through that program, and I was like, I'm gonna go back to school to become an engineer.
Yeah.
But I went and became an electrician for a while, and then went back to become an engineer.
So
Did you point at the screen the second time
No.
too? Or
Magic 8 Ball, that one.
Yeah, you Magic
No.
8 Ball for that one.
way more advanced.
Yeah, way more advanced. Yeah.
So we kind of talked about present, where things are at. Why don't we forecast into the future? You know, what do you see happening for construction in the next, in the immediate term, let's say, and then maybe why don't you take a stab at the longer term?
Yeah.
So I would say I think there's going to be some evolutions, kind of one of those spoilers that we talked about.
Mm-hmm.
We went from 600 volts to 1500 volts, and 1500 volts was only like 2015, somewhere around that time frame. It's only been the last 10 years. I think we're going to see a lot of 2 kV projects. I would be very surprised if we don't start to see them by the end of even this year or possibly. I know it'll be by next.
Yeah.
But I'd be very surprised if you don't see that even sooner than that.
And share what that change will do.
So essentially, what's interesting is when you have a piece of cable, the diameter of your cable is really determined by the amount of current you can put through it. The insulation, the outside of it, really, which is like the cheap rubber outside of it, is controlled by how much voltage you put on it. So right now, with the cost of metal, right, it's cheaper for me to just add some more rubber on the outside of it, keep the conductor the same size. And then the cool part about it is if I increase my voltage by about 33%, I can get basically 33% more power, adding a little bit of rubber on the outside of things.
Wow.
And I get 33% more power out of more or less the same items that I had before.
Yeah.
Wait, say that again. So what are you talking about? So like if you have a
Civil.
tracker,
What can we say?
Yeah, civil. I know.
Civil. He doesn't get it. All right.
Wait a minute. So you have the same tracker. Let's say you've got, or just a module. If you have a 750 watt module, that's a big module. But you're saying by adding some rubber on the conductor, it'll
So
put more juice in there?
So it's a 750 watt module.
Yeah.
But the voltage it puts out is about depends on the brand, depends on the module. But let's just say it's somewhere around 35 volts. Or, well, let's make our life.
So this is the string sizing,
makes
right?
our life, yeah,
Or whatever.
the
So
string
then
sizing,
you're gonna put all these in
So you
series,
can put more of them in
and then your
series.
limit is 1500. That's the limit.
Your limit is 1500, exactly.
Is for how many you can stack into that one final wire,
Yeah.
if you want to say it like that. So then now you can
Just
just
2,000.
so we might build a tracker that's 33% longer instead,
Well,
or
you'd have the same number of modules, right?
Yeah.
So like if I had 100,000 modules, I'd still have 100,000 modules. The difference is all the wire that I hooked up to it.
Yeah.
Would get to stay smaller as if it was a smaller voltage, a smaller system.
So cheaper.
So it's cheaper to. So overall, I don't want to say cheaper.
Wow.
No, I'm just kidding.
Is the current?
No, I mean, yes, it really is. Like for the same amount of, so essentially the idea is for the same amount of power that I put out, I get 33% more power for roughly the same cost as what it would cost if it was a 1500 volt system. I mean, obviously there's some change because you have to have more spacing between your pieces of equipment. You know, like that's going to add more like materials and, you know. So
like would the acreage grow then
no,
also?
so
the footprint and the layout would be the same.
Yeah, the footprint of the layout would be more or less the same, but you get 33 more. Even that's a savings. You get, you know.
You're just getting more power.
More power.
For the same
material cost.
Material cost.
Yeah.
Essentially.
Is there a trade-off in the current that's happening, or
higher voltage, lower current usually?
Yeah. So, well, I mean, yeah. So basically, if you maintain the current at the same level as you would if you had 1500 watt modules versus 2000 watt modules, you get more power out of it, but you have the same current level.
Yeah.
why was it 1500 in the first place?
Well, it wasn't. What was it? 600?
Well,
It was
600,
600 volts in
yeah.
the first
Yeah.
place.
Yeah.
So, well, what's interesting about that is a lot of things evolved that way.
Yeah.
You look at kind of, well, why did it go from 1500 volts to 2 kV? I think a big reason for it going to 2 kV is the fact that like the cable itself is already rated for 2 kV.
Mm-hmm.
It's already used for
They're 2 kV rated cables. Yeah.
the 2
exactly.
kV rated cables. They were already designed for that.
Mm-hmm.
And part of that is they used it in different applications, and you know you can go into all types of reasons why. But essentially, the reason it's jumping now is because the technology has kind of gotten there where you have like and there's enough proven technology where you can kind of do some math and say, okay, if I do this, how is it going to respond?
Yeah.
It's kind of like, I mean, why didn't we go straight to 1,000 horsepower car 10 years ago? And it's like, well,
I like horsepower.
yeah.
I'm into it. Works for me.
Yeah. Yeah. So yeah, then you're saying for sure next year you're thinking this is going to come.
I would be very surprised
Yeah.
if it doesn't happen next year.
Right. And so that just leads to the idea of, do you think, I mean, where does that stop? Right. Like 10 years from now.
Yeah. 10 years from now, so it gets interesting as you start to get higher and higher voltages on that side.
Yeah.
You start to present your own system of problems.
Sure.
And I don't want to like bore the civil engineer.
Right.
So
I was listening.
So, but I think the next step you'll probably see, and this is me kind of spitballing, is I think you'll see some of like the medium voltage side of it start to increase.
Yeah.
So for those of you viewers out there who don't know this, essentially you make DC power with solar panels, and then you use an inverter to create that into AC power, which is essentially what we use in our outlets. But we have to get it a very far distance. In order to get a very far distance, you got to increase the voltage so that it can go a very far distance. I can get way more technical than that, but I don't think anybody cares.
I'm listening.
But the higher voltage you can get it for, the further you can send it,
Yeah.
and the cheaper you can send it further for. But the downside is, like everything, there's spacing, land constraints, and things that go along with that. So I think what you'll see is the 34.5 side of that, the MV side, will start to go up too.
Yeah. It's like 6 to 9 kV.
Yeah, I think 69 kV will be kind of a big jump.
So there's a project I know of
there.
that has 6 to 9 kV. Yeah.
And the idea behind that is copper has become expensive.
Yeah.
Aluminum has become expensive.
Yeah.
And rubber is cheap. So if you can add more insulation to things, and it's not just rubber. I know somebody. I'm sure some commenter on there is.
We're going to get our commenters.
Yeah, is going
on
to
that.
explain.
What cables are made?
Yeah, what cables are actually made of.
Yeah.
But that's not the point of this conversation.
Right.
What is the point of this conversation?
I haven't figured that out yet, but I'm doing my best.
What is it you say you do around here?
Yo, dude. Back to Office Space. Love it. Love it.
Yeah.
Was it Kung
so
Fu
that's-
Mondays, baby? Kung Fu Mondays? Kung Fu
Yeah.
Mondays.
So that's talking about the that aspect of it. What other technological trends? Any other things you're paying attention to closely?
So I would say, I think one of the things that we'll find is like within the substation, I think we're going to start to see an elimination of SF6 gas breakers. SF6 gas is used for an insulating material. And there's a lot of concerns over it being like a greenhouse gas that's like 25,000 times more of a greenhouse gas than normal air is. And essentially a greenhouse gas, I mean, for small short story definition, is basically anything that can hold heat. That's better than air, the normal air we breathe. And this thing's like 25,000 times more powerful than that, like,
Wow.
as far as like being able to store that energy. So when you factor that in, it's basically like, hey, why are we doing this? Especially when we're making renewables. Like, is there a different way to do this? the state of California has already put in place a ban basically that says like, I forgot what year it is, but in the coming future, they're like, hey, we're not going to allow any new projects to have this. And so we're going to start to see a trend of that. But at the same time, that's causing a disruption in the industry. California being such a a giant GDP in general. Yeah. And then knowing that other states will follow that, the kind of industry is already kind of shifting towards replacing those cloud breakers with like different technologies.
And what exactly is the gas doing in the application?
Acts as insulation. Isn't
Yeah, it acts as insulation. So essentially, I mean, if you rewound 50 years, you would have found breakers that wouldn't fit in this room, and this room is pretty big. I mean, for you guys, probably can't see this room, but it's probably 15 feet long. Probably 15 by 15.
Let's call it,
And you wouldn't be able to put a 138 kV breaker in this room because it had giant. For those of you who want to Google it, just Google a 138 kV oil circuit breaker, and you'll find these three giant barrels that would probably a 20-foot by 10-foot footprint. And then you were able to take that and go to a breaker that is probably 8 feet by 8 feet. And basically extremely condense down your spacing. On top of the fact that, like now you have to deal with all that oil, you have to process that oil regularly, you got to do all the maintenance that goes along with it, as opposed to an SF6 that pretty much lasts as long as the breaker will last. As long as the breaker is good, it'll last that long.
I mean, it seems like the scale you're talking about here, like to the layperson, it seems like me, it seems like is that really a lot of gas? But or is it just the fundamental concept of like, oh, this is 25 times heavier than air? Maybe we shouldn't be producing this in general.
Yeah, it's not that it's heavier than air; it's that it holds more heat in than air.
Yes,
it'll store heat energy. So instead of like it, kind of going off into space, it just gets trapped in the gas.
It
gets stuck in the gas, which is in our atmosphere. So you're kind of done. The gas is heavier than air, but that's kind of a fun story too. So you can actually Google a bunch of like people breathing into it and like using it like helium. It does the opposite effect of helium.
Deep voice.
It's very deep voice.
Yeah.
Wait,
that was good.
Yeah, that was
really good.
He just what you didn't see off camera was he just had some of the SFS and
So the it's been a long time since I did substation design, but like GIS.
Yep.
Yes. So was that's not.
That's literally gas insulated switchgear is what it stands for.
Right, I know, but is that S7?
That's SF6, yeah. Sulfur hexafluoride.
Okay, yeah.
And so we'll start to see changes in technology.
What do you think it's going to be instead?
So actually, what's interesting right now is actually a couple manufacturers have just released vacuum breakers that are that big.
Okay.
And that was just kind of interesting and a new technology. And the reason I do the little air quotes is for 34.5 kV and below, vacuum breakers have been a thing for a long time.
Yeah.
Like probably 30 some plus years, not more than that.
So reasonably, it seems like, well, what can't you just scale that
up? Exactly. But you can start to get into like size constraints and issues of maintenance and weight, and I mean there's a whole bunch of balance of stuff into like all the cool stuff that engineers get to do and figure out.
What about the so we talked a little bit about high voltage segment. What about the battery industry? Any thoughts looking into the battery?
So I think I think there's two things into this. I think batteries will become more prevalent. Technology is getting, and there's new technologies coming out that
like all the time.
All the time. Yeah. I mean, and what's interesting about our market and that kind of lead me into one of the things I think will be a big major change within solar panels themselves, is the market the way it stands right now is as you start to get like this big demand, right? All of a sudden you're getting you talked about the firms that are getting involved and throwing money into it to build like to hold transformers in line. Well, if you have that ability where there's money here and there's demand, it's like you have start to get all these investment firms investing in new technology, investing in being the new thing that they can sell and make some money on, which kind of attracts more and more like diversity to the market. That said, on the solar panel side, I think an interesting technology to watch is going to be perovskite panels.
Yeah.
So
Proddy when he loves.
I know.
perovskite.
Yeah. Proddy, where are
Proddy,
you?
that's his favorite thing to say.
Yeah. Perovskite.
Our other co-host.
Yeah.
Oh, okay.
Yeah. Sorry, Proddy, who's in.
Yeah.
He's not
Proddy,
here.
yeah,
Who are
yeah.
you talking about?
I'm like, he loves perovskite.
There's nobody in that.
Yeah, I
chair.
know. That's normally his seat.
He's still alive.
What exactly
for
is
the
in
record.
this water, by the way?
Yeah. Don't worry about it.
So yeah, no, I think perovskite panels are going to be a major change because on the project, I kind of mentioned that 50% of the cost is modules ish,
Yeah.
roughly, kind of ballpark number. Well, perovskites have the opportunity to be about 10% of the cost of a project.
Can you quickly tell us the difference between the typical modules that we're using in utility scale solar versus what perovskite would be?
Perovskite, it's literally just a different material that the wafers are made out of that collect the light.
And they're just more efficient.
They're more efficient essentially.
Yeah.
The downside to them is that it's not all like rainbows and gravy here. The downside is they are predicted to not have a life that lasts as long. A typical module after about 25, 30 years is still 90% good. A bad module of one of the ones we have is probably 80% good.
Okay.
A perovskite panel, in theory, is only supposed to have about a 15-year life, so it's about half of that life. That said, if it costs you a tenth of it if it costs you a tenth, and you say, hey, instead of every 30 years, you got to replace it every 15.
Well, wouldn't that be? I mean, there's already a repower kind of factored into these projects, also, right?
Yeah.
So like that's just like, we'll replace them at 15 years.
And what are the chances over the course of 30 years you don't have them get hit by hail? If they're cheaper modules and they can get damaged by hail also, and now they're cheaper to insure, is there a whole benefit to that? So that's why I think perovskite, if it proves to be an actual 15-year life, the fear behind it is not really a proven technology. What if it ends up being 6 years?
Yeah.
That totally changes the idea. But you're starting to see utilities start to try them out and put them in small doses in small areas, as well as like NRail's modeling them to try to factor out like, hey, what is the life expectancy of this? What are we seeing for decay?
Yeah.
Because if we're really seeing a 15-year decay, these modules could be game changers.
How many years do you think before we see a full utility scale project with perovskite modules?
If I had to guess, which obviously I'm guessing, probably I would say probably in the next 3 years.
3 years? All right.
Russ,
what's your
I don't
bet?
think it's crazy far off.
Oh man, I don't know.
We should
5
ask
years.
Proddy what his
Proddy
bet
would
is.
know.
Yeah.
Okay.
He's
Yeah.
our tech guy.
I don't know. I think it's tough.
I'd be curious.
Because I think it's hard to predict that because, like you said, if we don't know that the technology is proven, who's going to invest?
Yeah.
We're talking about projects that are $500 million.
Yeah.
So I would actually say like, hey, for all the viewers out there, I think we should challenge the viewers to put what their prediction is.
Yeah. What's your prediction?
If you have a prediction for this question of when perovskite panels will enter the solar or the utility scale ground mount solar market, put your answer in the comments.
But I think we kind of did we not touch enough on BESS as far as like what we think's.
I think best. Obviously, like battery technology is really the limiting factor on it.
Yeah.
There's lots of advantage to it, and there's lots of debates on where the best place to put BESS is. I think most people don't realize that in order to maximize the width of the amount of time that you're producing solar, you actually overproduce solar during the day. Mm-hmm. So there's, you can put batteries on there that collect that overproduction.
Yeah.
And that's all to, just to increase like, hey, I want to be able to guarantee I'm going to hit this target from here to here.
Yeah.
Well, in order for me to hit the target from here to here, I got to make extra.
Yep.
At this peak kind of curve. So it's like, hey, how do I capture all that extra? So, throw batteries in there. And now what do you do with those batteries? Hey, at the end of that day, I can actually extend out even more time of that solar.
Yeah.
But then, the financials have to work out for that.
Yeah.
But I think what we're starting to see is as they start to tie into like grid stabilization and kind of the items that you'll lead with that technology, I think you're going to see more and more BESS appearing throughout the market. Just because now it's like, hey, I can always produce power too when it's cheaper and when it's less load and save that for during the day. And now you get into like the AC coupled BESS. And there's the people that almost like trade this for futures. Like, hey, I can buy cheap power from a power plant that's available at night, store it in these batteries, and then give it to you when it's expensive.
Yeah.
Yeah. Yeah.
That's cool.
So what is your thoughts on AC coupled BESS versus DC coupled BESS? This is like my favorite question because I have strong opinions.
They both have their places.
Sure.
AC has more diversity than DC does, but there is areas and times when DC makes sense.
Sure.
And there's financials that play into that too. as I'm sure you're aware. I am really curious. Just I don't know if I get to ask a question.
You can ask a question.
but I am really curious to know like what are your strong thoughts on it?
So just from a standpoint of designing, DC coupled BESS is much more difficult to design, and there's a lot more limiting factors of space. And so the DC coupled BESS projects I've done have been very, very, very challenging. Where AC coupled BESS is basically a substation.
Yeah.
So it's not as difficult. Not that I don't enjoy the challenge, but if I could choose, just from a design standpoint, it'd be AC coupled BESS.
Yeah, and I think one of the things I find really interesting about DC coupled BESS is why does nobody build like a skid that has their own power on it? Like,
Don't know.
Why do they make that as a separate design item? I don't know. Like
there's an opportunity here.
Yeah, I feel like there's an opportunity
really,
there.
There's
And even the inverter skid manufacturers are like, hey, we'll power everything. Oh, but the air conditioners and control systems for the BESS. If you need that powered, you got to put a separate skid next to it.
Yeah. I don't know.
And so that's something I've always found interesting.
Maybe we'll get there.
Maybe we'll get there.
I'm sure we will. Somebody's going to look at that and see the opportunity. There has to be.
I agree.
Do you have any opinions on like battery chemistry technology or anything like that?
I mean, I would say my expertise is less focused with that than other items.
Would you care to make a completely unbased opinion?
I mean,
Or outlandish.
I think outlandish. I would love to see magic batteries.
Yeah, magic batteries.
Magic batteries would be really cool. No, I would say. I mean, I think lithium you're going to start to see less production of lithium in general. I mean, there's other technologies that are kind of disrupting that market. Plus, like lithium in and of itself is like an amazing it has an amazing capacity to store batteries, at least for within our own technology. But it's also a very angry system, right? I mean, if you charge it too much, it gets mad. If you charge it too little, it gets mad. Or I guess discharge it too much.
Yeah.
Anyways, so I think overall you're going to start to see a change in like in going away from lithium. And what's interesting, a lot of people don't realize, I don't think, is like lithium batteries. Everybody thinks like they're cool, newer technology because it's just recent people hearing it. It's like 1980s technology.
Yep.
Right.
As you start to see some of the batteries things, and lithium is kind of cool because it's small, compact. But if size isn't that much of a matter, if I can always build up on a battery rack, like, is it really the best idea? Especially when you have like the flammability concerns and So I think technology will shift away from lithium at
the utility scale at least.
Utility scale.
It's good for cell phones.
It's good. Yeah, it's
right
great for us. It's like it's great for small
car,
laptops. So, what advice would you give somebody on skill stacking? What skills should they stack in renewable industry?
Oh, I mean, I would actually say focus on like AI prompting.
Okay.
And like a real heavy focus on and actually being able to build AI models. Because I really, really do I think that like the efficiency production, it's, everybody hears that old saying of like, how do we do more with less? How do we do more with less? And I think it's going to be more, how do you do more with the same?
Gotcha.
Like, how do you have the same number of people and increase production of what they can do? So I really think that if you could skill stack something that, and I would say this is not even just applicable to renewables or engineering in general. I would say in life in general.
Sure.
I mean, there's some I mean, I'm not gonna. Well, actually,
You got the mic, man.
I use the AI, like my AI at home, to do like all kinds of things, like write emails to like.
Yeah, we talked about this
like to write emails and make my life easy. Like it's like, hey, how do I send an email with this information to whoever? And it's like, okay, cool, I'll do that for you. Boom, and spits it out.
Yeah.
Like how do you take a picture and say like, hey, what is this device and how do I learn more about it?
Yeah.
I mean, but I think like being like, to me, it's the same thing as like if I was giving somebody advice like 30 years ago, like, hey, what do I think you would need? I'm like, hey, I think you need to take a typing class. I think you need to take a Microsoft Excel class.
Yeah.
I think the advice I would be giving somebody right now is, hey, how do you like take an AI class? Watch some YouTube videos, figure out how to. So prompting is super important, and then being able to build your own models, I think is going to.
What do you mean by a model exactly?
So, what people don't realize within like a lot of the AIs, like ChatGPT will learn from any information you put into it, which is also a little scary, right? So any information you put into ChatGPT, to my understanding, will it'll use that information and upgrade its model. But not all the other systems are like that. But something you can do even with ChatGPT is you can actually basically download its model as it sits today.
Yep.
And then you can say, hey, I want you to learn this, that you don't include this book in your knowledge. I'm going to upload this book into your knowledge, and I want you to learn this book. And it will actually go through it and try to analyze it in a million different ways using its model to basically incorporate that book into it. And I'm obviously way oversimplifying this. But essentially, you can actually, they even sell book scanners now that will scan books. And I think when we get into some of the QC stuff, you'll be able to provide drawings into them and actually say hey, what do you see inefficient about this drawing?
Yeah.
But you'll be able to teach it drawings. We use symbols on our drawings for what a transformer is. We'll use symbols for what an inverter is. We'll use symbols for what a module is. And we'll be able to teach, you can actually teach the AI to look at the drawing and basically be able to parse that information out. And you can actually ask it questions hey, how many modules did we design last year?
Yeah.
And it'll go through every drawing you've ever scanned into it, count all those modules and say hey, you engineered 20 million modules.
And it'll be super fast.
And super fast.
Yeah.
When did you say you kind of had the aha moment with how it could help your work?
Or
your life, or anything.
Or life in general. I would say it was relatively quickly when somebody showed me the power of it and how much information it has on it. And you can ask it questions. You can say hey, do you know the NEC? And it'll be yeah, I know the NEC. Or it'll tell you I don't. And then if you download a version, you can actually buy a legal copy of the NEC. I'm not asking you to do anything illegal. and you can actually upload it into it. And you can actually say hey, now you know the NEC, and you can ask it a question.
Yeah.
Hey, how do you do this? But I think the first time I saw somebody have it review a contract and tell me whether or not this was in our scope or not, and then be able to tell me what page it's on, and what the information was, and its determination.
It's relatively straightforward how you would do that. You'd be all right, here's our information. Analyze our information. These are our terms, and then here's the contract. Analyze the contract for these terms.
Yeah.
Done.
And what's interesting is you can actually link models together. So you can take like a Gemini model, and you can take a ChatGPT model, and you can link them together, and you can actually say hey, talk amongst yourself and come up with a best answer, or what you think is the best answer.
That's wild.
And it will actually spit out hey, Gemini said this, ChatGPT said this. Together, here's what we think.
So, what do you think ChatGPT's answer is for if Taylor Swift and Travis Kelce is real or not?
We should test this. I don't have my phone, but that'd be an interesting test.
I got it. You got it? Okay.
Do you have the app on your phone?
You got it. He's got it. I don't have my glasses on. I can't see.
I'm gonna. I can't have my glasses.
I thought I was the old guy.
I can't see without my glasses on.
All right, I'm gonna speak it to text because. I also noticed that I know we're getting way off base here, but I feel like ChatGPT, as you're using it on your mobile device, should be only audio input. You should have a button to speak it, and you should not type anything because you should just speak to it. Anyway, here we go. Is Taylor Swift actually in love with Travis Kelce, or is it a elaborate money-making scheme?
There's no definitive way to know someone's true feelings, but from what's publicly available, Taylor Swift and Travis Kelce seem genuinely happy together.
Whatever.
They've been openly supportive of each other. She's attended his games, and he's traveled to see her perform. Their interactions don't look staged, and they don't seem to need a relationship for publicity, as both are already extremely successful on their own. Of course, celebrity relationships always have commercial benefits, but that doesn't necessarily mean they're fake. It's possible they're simply enjoying their time together, and any financial gain is just a bonus.
See, it's possible they actually like each other.
It's possible.
Okay. All right, Mike. I got a couple gifts for you here.
Cool. Thank you.
Thanks for coming on the podcast. We're really happy to have you back a second time, and would love to have you on for another time. And
That's awesome.
Tell your kids your dad's famous.
Yeah.
He's actually famous now.
I'm actually
really
famous.
famous.
I mean, if you're on it twice,
Twice. Famous.
And they have double the number of viewers.
Yes.
Yeah.
Double the number of viewers.
Yeah.
You got even more swag.
I got even more swag.
Yeah.
And actually, it's pretty cool logoed.
Yeah, everything's branded here. It's merchandising.
Merchandising.
Merchandise.
Yeah. That's going to do it for us on the Sounds of Solar podcast today. I'm Christoph Bruhn. Thank you for listening. Thank you to Russell Hamilton. Thank you to Mike Benitez, our wonderful guest. And we'll see you next time on the Sounds of Solar podcast.
Peace.